In this example, I want to discuss with you how we can calculate the mean and the standard deviation of some continuous data, but this time we've got the data grouped together into some categories. So a typical example could be, for example, we have a plant and that produces some kind of seed pods, something like that. And in this seed pod, there are the seeds arranged. And we want to know how many seeds are there on average per pod. So we take a number of pods and analyze them, and just for simplicity, put the number of seeds into these categories. So, for example, the category of 0 to 9 seeds per pod, and we find that we've got 8 pods that fall into this category, 10 pods that fall into the category between 10 and 19, and so on and so forth. And you get the gist. We don't find any seed pod with more than 50 or more seeds, probably because they just simply don't have enough space there. So what we should do in the first place is have a look at our distribution of the seeds per pod, and we can do that very easily. So I just highlight the ones that I want to, the cells that I want to look at, and under Insert I go to Recommended Charts and I use a bar chart in the first place. So that would give me here the distribution of the seeds. I don't need this title. And what we see here is that we've got this bar chart, but in a way it's a little bit misleading because the categories here should be very close to each other, should be not having this gap in between, because we've got 0 and 9 seeds, and then immediately next to it would be 10 to 19 seeds. So what we can do is we just simply click on one of these bars here, and we change the gap width, and we bring that down to 0. And now we get actually a really nice histogram. And typical for a histogram is that there are no gaps between these bars. So that would be actually a good histogram. So here we have the categories of seeds per pod. Seeds per pod. And here we've got the frequency or the number of observed pods. Frequency, and that's the number of pods with that seeds. And that is a very good histogram without any gaps in between, because we don't have any gaps in between. And we can already see that we have sort of between 30 and 39 seeds per pod. That has the highest frequency, so that would be our mode in this case. The mode of that would be between 30 and 39 seeds per pod. Okay, now how are we going to calculate the mean of this? Because that's a little bit tricky. When we look at, for example, Likert type data, we can just very simply do that by, we don't have the data in a group format, but we can work around that in that we just simply determine the midpoint of these categories. And the midpoints would be actually exactly as it says, it would be here in the middle of these category. And we can very easily determine these midpoints Now, the last category doesn't have a midpoint because it can be anything, but luckily we don't have any seeds in here. So we can just simply say this would be the middle between 0 and 9 seeds, so that would be 4.5 seeds. And I make this a little bit larger so that we can easily see this. We have here 14.5. So what we can do is we can let Excel do all the hard work, and we do it like that. Is that correct? Yeah, between 40 and 49. The midpoint is 44.5. Now what we can do is we can calculate with these midpoints. We can now use these midpoints to calculate the total number of seeds. So for the mean, we calculate the total number of seeds and divide it by the total number of pods. So how many pods have we looked at? We just simply sum up the number of pods that we have here with the sum built-in function. So how many pods have we analyzed? We just add them up. And we find that we have analyzed 74 pods here. Okay, so we've got the denominator, the number of pods. Now we need to calculate the number of seeds, and we do that by multiplying the midpoints with the seeds with the number of pods. So this is equals the number of midpoint, or the midpoint times the number of pods. So here we would get roughly 36 seeds, and we can add them all up. We don't need to worry about the last one here because we don't have anything in it. Let's make this a little bit more visible. So this is the number of seeds that we have. And now what we need to do is we can add up the number of seeds, again with the sum function. So we've got the sum function and we add up the seeds. And we get 2073 seeds. Now for the mean, to calculate that, we just simply divide this number of seeds divided by the number of pods, and we would get equals 2073 divided by 74, and we would get roughly 28 seeds per pod. So that would be our mean in this case. There is, of course, an uncertainty in it because we haven't recorded the exact number of seeds. We just have this in categories, but it gives us a good idea how many seeds on average we would expect per pod. So 28. That would be the mean of the seeds. Now, we also want to know what is the spread, and we can use the variance for this calculation. And the equation for the variance is written here. So we take the number of pods, we multiply it by the difference between the midpoint and the mean. That's the mean that we just calculated. We square this difference, and as I said, multiply it with the pods, and we sum it up, and then again divide it by the number of pods. So let's do that. First of all, we calculate the midpoint, the difference between the midpoints of the seeds. So this is this column here, minus the mean and square that. So that equals the midpoint minus the mean that we've just calculated, and I lock this cell that it doesn't change and square it. We also make these numbers a little bit larger so that we can easily see them. And I let Excel do all the heavy lifting. So these are the differences between the midpoints and the mean and squared. Now I multiply it by the number of the pods. So that is the number of pods times the difference here that we've calculated. And again, Excel is doing all the heavy lifting. And now we have calculated this part here and the number of pods, and now we calculate the sum of this. So we calculate the sum. That gives us 11,486. So we've got the numerator and the denominator, and we can easily calculate the variance. So that is equals the numerator divided by the 74 pods, the number of pods. That gives us 155.22. Well, seeds per pod squared. And very often we find that the variance is not a very good measure of the variability because it doesn't have the same unit as the mean, but we can very easily calculate the standard deviation because we know that the standard deviation equals the square root of the variance. So all we need to do is we need to calculate the square root of the variance for our standard deviation, and we get a variance of 12.45. Again, we need to be careful with that because since our data are grouped, there is a certain variability in it, but with group data, this is the best way we can actually do these calculations. So I hope this makes sense, and thank you very much for watching.